Hello everyone, my name is Michael Irwin and I'm excited to be here for DockerCon 2020 from the comforts of my own basement. Hope everybody's doing well, and I'm calling in from Blacksburg, Virginia. And today we're going to be talking about simplifying all the things with Docker Compose. So just a little bit about myself. Like I said, my name is Michael Irwin and I work at Virginia Tech, and I've been here since 2011, and I'm currently leading efforts to build what we're calling the Common Application Platform. Won't get too much into it, but it's a lot of Kubernetes and Prometheus and just CNCF stack, and we're really excited for this. I also get to have the opportunity to teach with the computer science department. I'm an adjunct faculty instructor there, and even just this past semester taught a class on containers. So really excited to be able to share some of these learnings and expertise with the students here at Virginia Tech. I'm also pretty heavily involved with the community. I am a Docker captain and also run the community meetup. So anybody coming from the Blacksburg meetup, hello. Great to have you here. I'm also, outside of work, I'm a family guy. I'm a husband and dad to 4 kids. And in fact, actually today, the day that I'm recording this, is my anniversary. So, and we've got a 5th kiddo on the way. So are we going to break the girl streak or not? Time will find out. And you'll have to follow me on Twitter if you're interested to find out as well. All right, so let's get into our talk. Our talk is going to be focusing on the efforts of a dream team that we're just calling Alice and Bob here. And Alice and Bob have been working on an application, and they're still pretty new to containers. And so what they're most excited about is the ability to have the same environment locally as they do in production. So if they build a container and it works on their machine, they've got pretty good assurance it'll work in production. Now, the application that they're working on will probably look familiar to at least some of you, as it's the new getting started tutorial that's being shipped with Docker Desktop. And so whether you use it for a grocery list or to-do list or whatever, who cares? It's just a simple app. Now, Alice and Bob, as they have been getting started with containers, they followed a workflow that looks something like this. And while some of you may laugh at this workflow, it is a workflow that I see quite often with teams that are getting started with containers. So as they are writing code, they build their app using Docker build. In this case, they're just tagging it with my app. Then they run their container and they expose the port mapping 3000 onto their host. It's a node-based app in this case. And then they open up their browser and check it out. Okay. And then they recognize, oops, some things aren't right. So let's build our new image after we made our code changes. Let's stop the previous one. Let's remove the previous container that's running. That's why they named it, so that it's a little bit easier to stop and remove it. They don't have to look up the container IDs. And then let's start the new one and let's check out the changes and open up the browser and find out that it's not quite working, and just keep going through this cycle. Now, the advantage here is that if it works locally, they know that it will work in production. But man, this is a big feedback loop. And so our first best practice that we're going to just talk about is use Docker Compose to replace the Docker run commands that you're calling over and over and over again. And the reason why that we can do this is because of the way Docker Compose is actually structured and created, and the way that it works. So what actually is Docker Compose? I'm a big believer that before you really start to use a tool, you need to understand a little bit of how it works and its motivations, and how it fits into the ecosystem. In order to do that, we need to understand Docker itself a little bit better. So the Docker architecture, again, we're not going to get super deep into this, but it's important to recognize that the Docker daemon is at the base of this. And the Docker daemon is what is actually starting the containers. It manages the volumes and the networks, and DNS and lots of other pieces that are going on here. Now, the Docker daemon, again, is pretty low level. And so what Docker did is they exposed and basically wrapped the daemon with a REST API. And that REST API is available at var run docker sock. And the Docker CLI is actually just making requests to that. So actually, if we take a little sidebar here, I'm going to jump over to a terminal, and I'm going to do a curl command in which I'm going to curl and ask for what containers are running on my machine here. With the curl command, I'm added the Unix socket flag to say, instead of curling against a remote endpoint, I'm going against a local socket. And when I run this, I see in the response that I am getting a response from the Docker daemon, and well, I've got no containers running right now. that'll change soon. I can also, let's clear this and let's go back and let's change this to version, and I'll also still pipe this to JQ, and we can see the full details of my app that's running. And again, so I can see all the different things that the through the API that are available for my that are running on the daemon. If I actually switch over back to Chrome, Docker documents all this. And so if you wanted to create your own custom plugin or custom tool that hits the Docker CLI against the Docker socket, well, here's the API to do it. Now, most people aren't going to be actually interacting with that, and that's okay. But the var run Docker socket is where all that's happening. And in fact, that's what's the Docker CLI, again, is using. When you do a Docker PS, it's making a REST query against that socket and then just formatting it in a pretty way in the CLI. And that's how it's working. So why do I mention that? Because, well, we can swap off the Docker CLI with something else like Docker Compose in this case. And I hope you enjoy my graphical skills there. Scratch out the CLI with Docker Compose. But with Docker Compose, it's a higher level abstraction tool that lets us manage multiple containers, and we can define our environments using YAML. With it being a YAML file, we can version control this, and now I can share a YAML definition with somebody else, and they can just use Docker Compose to spin up their environment and go. The last thing I want to mention here too is that Docker Compose is an open specification, meaning that Docker has made the Compose spec open to anybody. And there's a lot of industry partners that are working to extend that specification to do who knows what. And I'm excited to see where it might go in the future. Some of the basic Docker Compose commands that we'll be using throughout this session and are the most frequently used are Docker Compose up, spin everything up, Docker Compose down, tear it all down, and Docker Compose logs, where we can see the log output from all of our containers in a single stream. So now going back to Alice and Bob, now that we've seen the tools, how can Docker Compose help them with where they are right now? So previously they were doing a Docker build and a Docker run. So let's make a Compose file that makes this a little bit easier. So we'll make a Compose file, which is named docker-compose.yml or .yaml, depending on your organization and your desire there. And the first thing usually in these Compose files is a version. Now, the thing I want to mention here is a version is the schema version for the rest of the document. So what flags, what options, what config is allowed to be specified based on that version. And for the most part, I always recommend people to use the latest version. There's not really much reason to use an older version. Compose has always been very good with backwards compatibility. So in this case, we're going to use version 3.8. And the next thing we do is we define the services. And the services, think of them as what containers are we going to run. In this case, we want to run a container service that we're just going to call app. We just pick that name. It doesn't really matter. Now, when we specify a service, we have to give it an image. What image is it going to use when it runs? In this case, our image isn't built yet, and so we can use the build directive to tell Compose to, hey, build an image, and then use the output from that build as the image for this service. And so we specify build // and the / meaning just this current directory, and that's where the Dockerfile is found. So with this Compose file, all we need to do is add the port mapping, and we're good to go. Now, one of the things I'll mention about the port mapping is this is, again, the short syntax that came from the CLI. Compose does have longer syntax for many of the different things, including like volume mappings, etc. So if your team keeps getting confused of which side is host port, which side is container port, you might want to consider switching to the long syntax. Totally up to you though. And with this, we have a Compose file and we can spin this up. And their updated workflow now looks something like this. Every time they make changes, all they have to do is run Docker Compose up, and we add the -- build to tell Compose to rebuild the image every time. If we don't do that, it's just going to build it once and then reuse it every time going forward. Now, one of the things you might recognize is, well, this is still kind of a bad workflow. The feedback loop is still pretty long, and you're right, it is. So one of the things that I highly encourage people to do is, well, shorten that feedback loop. Use tools that make sense. So build a dev focused container and that watches for file changes and then responds to them. And so we can mount our source code into that container and make things much faster. in order to do this, you need to explore what tooling, what capabilities are available for your framework. In our example here, we're using Node, and so we'll be able to use tools like NodeMon to be able to respond to file changes and restart the Node server, etc. But every framework might be a little bit different, so do some exploring there. So what's this look like? We're going to update our compose file from the one on the left to the one on the right, and we're swapping things around a little bit. We're now specifying a specific image. We're going to say we're going to use Node and we're going to use the long-term support. We're running a command, and this command, the reason I'm actually invoking a shell here is to allow me to do multiple things. So I can do both an npm install and then a run dev, which allows me to clone this repo and then do the npm install. I don't have to do any kind of first-time setup. It'll all just work at once. And in case you're not familiar with Node, npm install is just installing all my dependencies for my application. I set my working directory, I mount the code in, and things are good to go. One of the other things I'll mention here is I've got a volume for Node modules so that all my modules are stored in a volume on the same file system as the VM that's used for Docker Desktop. And this is mostly just a file system performance benefit here. But there's a lot of other good things going on in the works with Docker and that space. So I'm gonna switch over and we're gonna actually take a look at this. And in case you're following along in my Git repo, which I'll post a link in chat and on Twitter and whatnot, if you want to follow along, I'm at the compose tag right now. So let's jump over to Visual Studio Code, and we see the Docker compose file that we were just looking at. And with this, I can run docker compose up build, and this should run fairly quickly. And now if I go to my browser, okay, in localhost 3000, we see my app startup, and I can add milk and eggs to my grocery list. Hooray, it works. And now if I go back to Visual Studio Code, and if we actually look at one of the files here, so app.js, and let's make add one above more exciting, you'll see that it automatically restarted my application. And so if I jump back to Chrome and delete these two items after I refresh the page, then we'll see that it is more exciting. I need to add one above to actually get the full use of my list here. Again, so still pretty simple here, but it allows me to quickly now see changes being applied, and now my feedback loop is much tighter. Okay, so let's jump back to our slides. Now, the thing that Bob recognizes is, well, we've got our locations described in two different locations, or our environments described in two different locations. We've got now the compose file that's doing some stuff, and now we've got our Dockerfile that's got some other stuff. What if the images, the base images change, etc.? Great observation, Bob. So what we can do here is use multi-stage images to solve this problem. And typically, multi-stage images are used to separate build time and runtime dependencies. So what happens is in our Dockerfile, we can specify basically multiple froms to do different things, okay? And this isn't going to be a deep dive course in it, so you'll definitely have to look things up. But like, for example, in a Java world, if I were doing a Java app, I need to compile my Java code, so I need a JDK. But when I'm actually going to run in production, I don't need a full JDK in production. So why don't I just use a JRE? Multi-stage builds allow me to do that, so that I can have one stage that does the compiling, the other stage that has just the runtime dependencies. But we can also do the same thing for our local dev environments. And then in Compose, we can say, I'm going to specify a specific target, a specific stage for my dev environment. What's that look like in my Docker file? Let's take a look. So this was our Docker file that we had before that was just simply copying our stuff, do our yarn install, set a default command. And now what we're doing is we're splitting things up a little bit. So our final production image, which is at the bottom, if you actually were to look at it, it has all the same steps. But one of the things that we did was we added yet another stage, that's our dev stage. And this is installing all of our dependencies, not just the production dependencies, and then has a different default command. And what that allows us to do is then go back to our compose file, And now we can pull out the image and the command, the working directory, all those things, and just swap it out with another build directive. Now, the difference between this build directive and what we had earlier is we need to define the target now. So we want to define that dev target. And the way that we do that is we added a little bit of extra config. So our context is still going to say we want to use the compose or the Dockerfile in the current directory, but now we want to target the dev stage. So let's actually jump over back to Visual Studio Code and take a look at this. I'm going to tear down my stack that I had from before, down, and I'm going to clean my environment, and I'm going to check out the compose multi-stage tag. Okay, we'll close that, and I didn't actually close it. And if we look at my compose file now, I see the build, and it's targeting that dev stage, and my Dockerfile has the multi-stage build. Now if I do my Docker compose up build, we'll see that it tries to do a build. I ran these builds earlier, so it's already cached, and you might notice this output looks a little different, and that's because I'm using BuildKit for my builder. But my app is up, and it's running, and everything's defined in this single Docker file now. Now I don't have the environment split between the two different areas. We're not going to open up the browser because it's working the same way at this point. But now, again, it's all defined in one location. Bob feels better now, and you're welcome, Bob. Okay. So now Alice comes and says, well, we want to actually add a database to our application. Right now, all the data is just stored in memory in the back end, and we're at the point now that we want to actually scale it up and add a database to it. So how can we do that? Well, with Compose, we can actually just add another service. But one of the things I want to highly emphasize is how you start introducing other services and how you configure those other services, and how you configure your app to talk to those services and know where to find them and credentialize, that's a new word. Anyways, how it knows what credentials it should use. The 12-factor application that came from Heroku is a fantastic resource. So it's at the website 12-factor, so 12factor.net. And as one of the core tenets of 12-factor talks about configuration, which it indicates that configuration should come from the environment to the application. And so I really encourage you to think about how you can configure your app. So once you build your image, whether it's for local dev or pre-prod staging environment or your production environment, you can use the same config everywhere, okay? Or the same image everywhere, and then just reconfigure it. And so there's really two main ways to do this. There's using environment variables for configuration, and then there's using files. I highly, highly encourage people to use environment variables when there's nothing secret involved, but then use files when it's more sensitive, sensitive credentials, etc. So like API keys, private keys, that kind of stuff. Now, a lot of times you see environment variables and files being used together. So for example, you set an environment variable that tells your app where to find the credential for your MySQL database, for example. And so using them together gives you a lot of flexibility, and your app is not very coupled to a specific environment. What I then encourage you to do is do the same thing for your local dev environment. Practice that kind of level of indirection, because you'll know it works. And what you can do in your local dev environment is then just kind of plug in dummy credentials. In many ways, it also helps simplify a lot of things, which we'll see here in just a second. Okay. So for our application here, our team wants to use MySQL, and great, that's fine. So the compose file, it's wrapping it into two different windows here, but the window on the right is defining the MySQL service. They specify the image, and we're mounting in config that just has static files of what's the username, what's the password, etc. And the MySQL image documentation specifies that we can specify these environment variables to tell us where the user, the password, the DB is, etc. And then we also mount that same config into our app, and our app is watching those environment variables and then using that to configure itself. Okay, so let's take a look at our application here. We'll switch over to Visual Studio Code. I'll tear this down, and we'll spin up Docker Compose. Git checkout MySQL. Docker Compose up. And if we look at our compose file, we see MySQL. And if we look at our config directory, we see files for the user, the password, the database, etc. And if I switch over to Chrome real quick and refresh, we'd see milk and eggs already here. That's because I put them into the database earlier. And if we switch back to Visual Studio Code here, I can exec into that container MySQL. I'm going to use the user of to-do and a password of secret. Use the to-do database and select star from to-do items. And we see those items here. And so our app is using the credentialing here. And if I go over to Chrome, I just won't switch my view over. And if I delete eggs and now update select star from it, I see that it's been deleted. So my app is using those same config files to configure both the database as well as the application itself. I encourage you to figure out some way to do that to really test out how your app gets configured for different environments, and then get your dev environment to support that methodology. Okay, great. Now everyone can run it locally without worrying too much. Okay, you're welcome, Alice, again. Okay, so our manager comes to the team and recognizes, hey, our app isn't really a standard React app. And if you actually take a look in the code base, it's for the most part just a single JavaScript file that has the full React app. It's not doing the full Webpack and all that kind of stuff, which is fine for a little demo. But since we're doing compose, again, it's just another service to spin up. A lot of teams, when they're trying to add other services, whatever, try to figure out how do I mesh the back end and the front end to a single container and everything. But you've got different tool chains and different services, lots of things going on. Well, keep them separate. Who cares if they're separate versions of things? That's the whole point of containers. Let things stay separated. Okay. And then what we can do is we can put a smart proxy in front of it to handle, to figure out what should handle each request. I mentioned earlier that I love traffic, and so this is where traffic's going to get plugged in. And so traffic is a great reverse proxy that uses the environment around itself to configure itself. So in most situations, there's no static file that says a request with this host name gets handled by that container. It's learning it from the environment. In fact, we'll see this in just a second. It uses the Docker socket, remember that API we were talking about earlier, to query for running containers and then find out what's coming and going. And we'll see how it does it, but there's a hint on this slide. It uses labels on the containers to provide that configuration. So if we look at our compose file, we actually see that I'm plugging in traffic. I'm telling it to run in Docker mode, so it's going to watch the Docker socket. And then I just add a bunch of labels to my different services. So in this case, this is my backend, and I'm saying any request that has the host name of localhost and a path prefix of /items, which is all my API endpoints for this simple app have, this container is going to have it. Then I would spin up my React app, my React service, and let it handle all the other requests. So let's actually jump over to that. I'm going to quit out of MySQL here, and let's check out the split front end tag here. And I didn't tear everything down. I've made a little alias on my machine that stops all the running containers, so I'm going to run that real fast. Docker compose up, and you'll see a new service has started. And while that's starting, this is doing the new service is a front end, and I updated my Dockerfile yet again with another stage for my front end base, my development environment. And for its routing rules, it's going to handle all requests to localhost, but you'll notice that's the same for the backend as well, but it's a little more specific. So the backend's going to get all requests that are /items, and then anything that doesn't match /items will get passed on to my front end. Now, if I open up my Chrome browser, I'm switching back to normal ports now, so just localhost. And if I go to /items, for example, I'd see there's my item. So that's actually being handled by the API. Pretty cool. And traffic lets me do all this. And now I have a real React app. I can make changes to it. It's doing Webpack and live reload and all that kind of stuff. And all my devs have to do is just simply Docker compose up, and it's working for them. Great. This will help us build better apps and hire qualified front-end developers. I certainly think so, because now it's an actual front-end development environment at this point, and they'll be able to help out. So now our manager asks us, can we add some end-to-end tests to this? And that's a great question. Docker Compose can really help us do this, because at the end of the day, it's just another service. And so what we're going to do is we're going to identify the tools. Maybe our organization already has favorites for testing, whether it's Selenium or Cucumber or Jest Test or whatever, and anything that we can use to do end-to-end test, we can support. Selenium actually already has several container images that already have Firefox and Chrome bundled into them, which should make it pretty easy to do these kind of tests. The cool thing about Docker Compose is we can also specify a service to watch, and so Compose will spin up our entire stack and we'll watch a single service, and when that service exits, it will automatically tear everything down, and then whatever exit code came from that service will be what Compose passes, or will be the exit code from Compose. This works really well for CI builds, so if our test container fails, that means Compose fails, which means our CI pipeline would fail. And we use this all the time, and it's magical, okay? So some sample architectures of what this might look like. If you have just a simple app in a database, imagine like an API or something like that, and you just want to do API tests, by all means do so. Some of our applications are a lot more sophisticated, in which we might have a container that's got Selenium code in it, and it's talking to a Selenium server that's using one of their images that has a Chrome or Firefox browser in it, and that's actually going against the proxy and open up the website. We use mock CAS. In higher ed, the CAS authentication protocol is used quite a bit, and so we've got a mock service that allows us to mock authentication to do kind of persona-based testing, and then we can put our credentials in our code base and not worry about them being compromised or anything like that. So I'm going to jump over to the API test tag here, and we're going to tear everything down first. And I'm going to check out API tests while that's boop. Okay. And what we'll see here is there's no change to the compose file, but I added a different compose file. So there's a Docker compose test.yaml. The reason I did this is typically these tests will run as part of a CI pipeline in which I want to build an image, or I want to run an image that was built as part of my pipelines. And so I actually have an image named DC 2020 here. Now, obviously that's not a name that'll be in Docker Hub, but you can swap that out with whatever image name your CI pipelines might be using. And then we've got a test code base down here, which is actually building the API test project here, and it's just going to be running a bunch of API tests. So I can run this by doing Docker Compose F. I specify this other file now instead of the default, and I'm going to give it a project name of test and up exit code from, and the service name is test. This will spin up. It'll just take a couple seconds. There's not a lot of tests here. It's pretty simple. And I see that all my tests passed. My test container had an exit code of 0, and if I exit or echo the last exit code, I also get a 0. So hooray, it works. My CI pipeline would work, and we'd be happy. You rock. All right. So switching back to slides now to wrap up. Docker Compose can really be used to simplify our dev environments. And again, the goal here should be your developers should be able to git clone, Docker Compose up, and start writing code. And you want to really focus on shortening the feedback loop so that they can be as efficient as possible, but yet at the same time using environments that are going to be the same when deploying to production, etc., or at least as similar as possible. With Compose, as new services or new needs arise, it makes it really easy to just plug them in. They're just another service. It's really flexible to let you change the way that you think about things or the way that you develop certain applications. And that's kind of the whole point. Compose can then also be used in automated testing. And there's going to be a talk later today from Andrew Crumpler, who's going to be talking about integration testing with Docker and Compose. And so you should definitely check out his talk as well. And so with that, I'm going to wrap up and say thank you and open up the questions. There's a chat that's been going on throughout, and we'll go on for several days after the meetup. Otherwise, feel free to hit me up on Twitter at MikeSir87 and say hello.